Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome to this new mini-series for GOTO Unscripted called The State of the Art. This series will explore generative AI, of course, but also other emerging trends in things like platform engineering, new practices, new programming languages, and in this particular episode, security. I'm Charles Humble. I have over 30 years experience as a programmer, architect and CTO, and I'm currently working mainly as a freelance consultant, a tech journalist, an editor and a podcaster. I'm joined by Adrian Mouat. Adrian is a DevRel engineer at Chainguard, a company who makes secure container images. He also wrote Using Docker, which was one of the very first books on Docker published by O'Reilly, and was chief scientist at Container Solutions, where he led various research projects. And that's also where he and I met for the first time. So Adrian, welcome to the show. Thank you for doing this.
Thank you very much for having me.
So I was struck when I was putting this together. You were very early in spotting the usefulness of containers. So what was it that enabled you to see that? What was the thing that you saw in terms of the usefulness of them?
Yeah, I mean, that's a good question. So I guess I do have to thank Penny Resnick, who was one of the founders of Container Solutions that you just mentioned, because it was actually him that was first playing with it and showed me. The first thing I used it for was Python. So I don't know if you've used much Python, but it's this thing called virtualenv. And it actually has a sort of similar role to containers. It gives you like a virtualized environment where you can have sort of different dependencies than your other Python projects. So you can have a different version of, your Python libraries. But I always hated virtualenv for various reasons. And so I immediately started using Docker for my Python environments. And I found it like much cleaner and saner. Also, the big thing was it was very easy to give to somebody else. So I could put my stuff into a Docker container and somebody else could build and use it, and I wouldn't have to worry about their version of Python and so on. So that's where I first got started.
Yeah, no, that's interesting. So there's been an issue with containers for a long time, which is that sometimes the base images can be really slow to update. So can you talk about that? Why does that happen and why is it a problem?
Yeah, that's a very good question. It does get quite deep. So when we started with containers, one of the big things that Docker did, and it was a fantastic move, is they created something called a Docker Hub. And the Docker Hub was where they stored all their images and anybody could upload images. But it quite quickly turned out that you generally want the same sort of images to build on top of. And so we had these, what were called base images for all the Linux distributions. So you'd find like Debian base, Ubuntu base, Alpine base, and so on. And you still have that very much. Now, the problem is, both for a base image to get updated, we need the packages in the operating system to be updated, which means like Debian, Alpine, etc. have to do some work to update the packages and release those packages. And then we need Docker or whoever is responsible for building the base image to release a new version of the base image with those updated packages. And until both those things happen, yeah, you can have a base image that's out of date. I'd actually probably go further and say that it's really just the way we work has changed, right? We used to have these sort of long-lived virtual machines that we installed and we sort of tried to keep up to date over time. And that's no longer the case, right? Now we have smaller containers that we update all the time. Well, we replace all the time. So it's a different world, but most of our Linux distributions are still set up for the older world of VMs, if not actual hardware.
Right. Yeah, that's really interesting. You see there's a sort of similar parallel in my head with the sort of Java and JVM thing, where the JVM was designed basically to be this very long-running process. It's super slow to start up, and then it kind of sits there forever. And then microservices happened, and the whole nature of how code gets deployed is just different. And we had to kind of retool the JVM to make it work in that space. It's kind of a parallel there, I think.
Yeah, I think so. I don't think I actually got to why it's a problem. It's just that you end up with out-of-date software in your containers or your VMs.
Right.
And in some cases, that will be like a security risk. Like you'll have old versions of software with potential vulnerabilities in them. And
Yes.
also you're not using new features, etc.
Yeah. And I think as well, it's very easy to get to forget that when you're a kind of traditional enterprise and you've got lots and lots of applications running, that you can get these kind of, just having operations that update things in real time can be a real problem for a lot of companies, I think.
Yeah. Yeah. I mean, that's it. It's a different way of working. And I think it's very important for organizations to get their heads around, or their systems and processes around this idea of keeping up to date as much as they can. But yeah, we're definitely not there at the minute.
Yeah. Yeah. I wanted to talk as well about scanners because I think it's kind of important context for this discussion. So lots of companies have invested in tools like Sneak or Docker Scout or those sorts of things. And I mean, I'll be honest, I haven't got masses of experience of this, but what I have seen is there's a kind of issue where you run a scanner and it finds a load of vulnerabilities. But then for a lot of organizations, it's like, well, it's not really plausible to address all of these. So what do I do here? So I'm not trying to criticize the tools. I think they do a useful job, but I just kind of wondered if that's something you've seen, if you agree with that assertion, and if you could maybe contextualize it a bit for us.
Yeah. I mean, that's absolutely a problem. And that's kind of why Chainguard is a successful company. So, yeah, you'll run like the scanner and it'll find basically what a scanner will do is it will create a map or a index of all the software that it can find in that image. Now, the better scanners will get better indexes and find more things in an image. But at the base level, what they will do is they will go and ask like the package manager, hey, what packages are installed? So that's like your apps or your yums or your APKs. And that will return all the software installed via the package manager and their versions. Now, that's not everything. Better scanners will also go and look at binaries, and like a Go binary, you can also investigate which versions of libraries are linked in there and so on. So you can go further than just asking the package manager. And then, of course, there's things like NPM and PyPy. You can also ask those systems for a list of packages. So you already get the idea that some scanners are better than others. And then once they've got a list of all the software, they will compare it to a database of known vulnerabilities. So the primary one is like NVD. GitHub also has a big one of GitHub security advisories. And then all the distributions have their own advisories as well. And then by just cross-referencing those two, you get a list of the vulnerabilities that are potentially in that image. And yeah, the problem is, especially with the older scanners, all he did was he dumped out a list. And you're like, okay, what do I do with this? And exactly as you said. Now, some of the better scanners will tell you, okay, this vulnerability was added in this layer of the Docker image. So you can see if it's in like a layer that you have control over, if you like. So if it's in your own application code, then yeah, I can go and fix it. That's on me to update a library or use something else, for example. But if it's in the base image, like the base image that I pulled from the Docker Hub or wherever, and I've got the latest version, what can you do? There's almost nothing. We did used to hear of, I'm sure this still goes on, some companies have security departments that if there's a vulnerability, especially a high or a critical, they will send it back to the developers and say, tell me why this vulnerability is there. And they have to like go and investigate it and come up with a reason as to why it's there and also like why it doesn't affect the application. And one of the most annoying things about CVEs and vulnerabilities is the majority of them will not affect a given application. It's a very slim, percentage of vulnerabilities that are actually going to be exploitable in the wild. So we've created this industry with all this work, but very little, I guess, very low signal to noise ratio.
Yes. Yeah, absolutely. Yeah. So given that, what's the relevance of reducing image size in that context?
Yeah. So the first thing, one of the best things you can do is just reduce the size of your images. And this is, it gets into ideas of Distroless that will come on to it. Basically, the less software you have in an image, the less software there is to have vulnerabilities and CVEs, and also the less there is to keep updated. And yeah, I guess I can explain Distroless. So Distroless was basically taking that idea to an extreme. And we were saying, what is the absolute minimum amount of software we need in an application, we need to run an application? And I think you were going to ask about Google and where the Distroless project came from.
Yes, absolutely.
So
yeah, can you talk about that a bit? The Google Distroless project, the Google Distroless project, how did that lead to the creation of Chainguard? How did that sort of come about?
Yeah, well, I'll explain what Distroless is first, and it kind of leads on. So I'm not entirely sure how many people were all involved in the creation of Google Distroless, but certainly Dan Lawrence and Matt Moore, who are like the CEO and CTO of Chainguard, were involved whilst they were working at Google. And basically the idea was, let's take the Debian base image and just pull everything out of it that we don't need for the typical Linux application. Now, this is quite an interesting thought, because naively you might think, well, I program in Go. I'll just create a Go binary that's statically linked and put that into an image, and I don't need anything. I use the scratch image with absolutely nothing in it. And that is true for some applications. But what you find is that very many applications, it's not enough for. The first thing you'll come across is like TLS. So nearly all applications need to make an HTTPS call. And for that, you're going to need certificates. So now you have to add certificates into your image. And then you start finding things like, well, actually, you have to have a temp directory, because you can make calls in like base Linux libraries that require a temp directory. And then you start realizing, well, you also need like stuff under Etsy and a couple of other small things. And time zones a common one as well. So basically they made an image with those things in it that's enough to run the vast majority of sort of Linux applications, if you like. So that's where the idea came from. And just by having this really small, couple of megabytes image, absolutely nothing in it, there's no CVEs to be found in it as long as we keep it up to date. And that was fantastic. They also, at the same time, created a couple of images for things like, there's a Python one, there's certainly a Java one, which were really slimmed down versions of Java images and so on. So we went from requiring, a 50 megabyte or 100, 200 megabyte image for running an application to requiring like a few megabytes, which was an absolutely huge difference, not just in terms of security and CVEs, but also in like just what we're transferring and being quick to start up and so on. So that was a pretty major difference there. And basically at Chainguard, which Dan Lawrence and Matt Moore and Ville and Kim started, we took that to the next level. So we just said, well, okay, let's create Distroless-based images for all the software out there. And that's kind of the premise of Chainguard.
Right. Yeah. So if I run a scanner on a Chainguard image, what should I see?
Well, hopefully you'll see 0 CVEs. Now, there's a couple of caveats there. There will be I'm not sure what I could find today, but you will be able to find some images with 1 or 2 CVEs that we're either currently investigating or there's no known fix for. But one thing to be aware of is if you scan like an old image, like say I pull an image from Chainguard's registry today, I'll wait a month and then I scan it, then you will find CVEs, because of course all the software in that is now slightly out of date and there'll be 1 or 2 CVEs found in there somewhere for something that's been published in the meantime. But the interesting thing is, if you compare that to say you had another image that had very few CVEs, but was a larger image, what you'd find is that larger image will have much more CVEs, even if it had the same number, 0 or a very close number to begin with. If you left it for a month or two, because there's more software in there, you'll definitely see a higher CVE count compared to the Distroless image later on.
Right. Yes. And I have seen occasionally I'll get a CVE that's detected by the scanner, but then Chainguard says it's essentially not affected. So what's going on there?
Yeah. So most scanners should now pick up the Chainguard security feed. So it shouldn't actually tell you that. It should just be removed from the list. But say there's a CVE you're interested in, if you go to like images, Chainguard.dev, you will find like security advisories for all the images. And there's a separate security page as well that I can't remember the name offhand. And you can go and look up any CVE and you'll see like the status of it. So not affected, there's like several different states you can have. I can't remember them all offhand, but not affected, fixed, that kind of thing. Not affected means, for example, one thing that happens relatively commonly is there's like a Windows version of the software, and obviously
Right.
our containers for the Linux version. So there might be a CVE reported against the Windows version, but the data isn't clear enough, and the scanner's also marked it against the Linux version. And so we will issue a not affected saying, hey, we're not running this version.
Got you. Okay. Yeah, that makes sense. And then you also have Wolfi. So what is Wolfi and why do you have it?
Right. So that's the underlying operating system for Chainguard. So the way Chainguard works is we build everything from source. Now, there's arguments around this that you can go and look at from competitors. But honestly, I think this is the only real way to fix software and produce secure packages is to build them from source. So basically, we created our own Linux distribution to build absolutely everything from source down to the glibc level. So we're not like just trying to patch an existing binary or something. We are actually fixing things at the source level and publishing them. And also that allows us to be very granular. We can figure out how to split a package up so that, you're not pulling in, modules that you don't need or whatever, because that's just the package size, which is sometimes a problem that I believe that Debian, for example, has. They typically have larger packages, whereas our APKs will typically be a lot smaller. But yeah, just to solve this problem of CVEs, we had to go back to sort of the really low levels of Linux and create our own Linux distribution and our own tools to turn those APKs, those Wolfi APKs, into container images. So we're not using Docker build. We're using a tool called APKO that's open source and you can try out, and that will assemble APKs into a container image, which is pretty nice. But yeah, it's purely like we have to build everything from source to overcome these security things, which is why we created our own Linux distribution called Wolfi. Right.
Got you. Okay. So if I'm running a Chainguard image and I need to update it, what's the process for doing that?
Well, you don't. You wipe it out and start again. Yeah, you can, if you have there are Chainguard VMs now, which is the follow-on product. So we have full virtual machine images that are basically the same approach as our container images. But again, what we would really advise is not to run like APK update this package, but to replace it with a new version. Yeah, it's just that sort of level of immutability. And we used to do this. I'm sure you remember configuration management, like Puppet and Chef and so on. And that was just a mess. I mean, going back to your first question, this is how I should have answered the first question, because I remember using Ansible and Puppet and Chef, and it was just pain. It was just a mess. And then the second you use Docker, and you could just replace a container rather than trying to make sure it's the same version as your other 10 containers that should be doing the same thing, and they all had the same version of packages, but they all weren't quite the same, and you could never work out why. I mean, Docker just got rid of that problem, that configuration management problem. They really just wipe it out, replace it, and then you're absolutely sure that all these containers are the same. And that was, a momentous change, really. And that's what you do. You don't update, you replace.
Right. Yeah. Yeah. I mean, because there are some other things that come up, like if you pip installed something into a container or something like that, how do you handle that? Or what do you do with transitive dependencies and those sorts of things? So, I mean, again, I'm just kind of interested in the approach here. So basically your recommendation is generally just start again each time rather than trying to update stuff.
Yeah, absolutely. I mean, there might be some exceptions like data or config, but there's also an idea of, again, that you can tell that we were founded by Google engineers. So at Google, they apparently have this idea of build horizon. So say you've got like a microservice or whatever running at Google, and it's been running, I think it's like weeks, maybe 2 or 3 weeks. The code's not changed. So there's not really any need in terms of features or compatibility to replace that image or that container or whatever it is, that service. Mm-hmm. But they will pull that service down and replace it. The reason being that although that code hasn't changed, there may well be libraries inside it, or there may well be utilities or operating system stuff there that's slightly out of date. So they replace it and put a new one up. And that keeps things secure, and you don't find out you're suddenly running containers that are a year old and have critical vulnerabilities inside them. Right.
Yeah. No, that makes a lot of sense, but it's quite, certainly to me, it's quite new thinking still. It's a very different way from how I'd sort of traditionally think about these kind of things.
Yeah, absolutely. We're still going through this change throughout the industry. I do feel, I've never worked at Google, but I do get the impression that people like Google, possibly some of the other big 4 or 5 tech companies, really kind of were ahead of the curve. And one thing you certainly see is companies being born from people that have left those companies and they missed the internal tooling. So they built a company that's, a recreation of the internal tooling. I think like Prometheus might be an example of that, for example.
Yeah, I mean, the whole observability thing, I know Charity Majors, who started Honeycomb, talks about having used, I'm forgetting the name of the tool, but whatever the tool was at what was then Facebook. And basically creating Honeycomb to replicate the tooling she had available from an observability point of view.
Yeah.
And it's the same kind of thing. We are seeing this a lot. And that's a really healthy thing, I think.
Yeah.
Can you talk a bit about SBOMs? So Chainguard can automatically create an SBOM. Can you explain how that happens? How does the SBOM get created?
Well, again, we have an advantage because we build everything from source. So we know what's going into the images. I should say an SBOM is software bill of materials. So it basically describes everything inside your image and the versions of it and so on. SBOM, came about before containers and can be used to describe any sort of software. So I will say if you go and look at an SBOM, there's two main standards, SPDX and CycloneDX. And it's a big XML document and it's not the nicest thing to read and they get very verbose. But at its fundamental level, all they're doing is trying to give you a list of all the software inside the image and all its versions. Now that does get more complicated and more difficult when you get down to transitive dependencies. So if I install a package, but that package installs other stuff, does your SBOM pick that up and things? But at Chainguard, we create SBOMs for all our packages and that gets put into the final image. That also means that we're creating our SBOMs at build time, whereas you might find that a lot of other people build theirs after the fact. So they're asking the same way and actually, if you go and look at tools like Sift is part of Gripe. So Gripe is one of the vulnerability scanners you talked about. What Gripe will actually do is run Sift to create what's effectively an SBOM. It's, I think it has its own internal format that can be modified to be an actual SBOM format, but it will create effectively, the index of all the software in the image, which gets passed to the database later. But that's obviously created after the software is built. So we have the advantage of being able to create the SBOM when we build the software.
Right. Yeah. So it's I was trying to think of an analogy and it's a bit like the sort of food industry or something like that, where if you buy a ready meal and you have a list of ingredients, or if you're buying a piece of meat, you should be able to trace that back to the farm where it, started and all of that sort of thing. It's the same sort of idea at some level, I guess. It's kind of like, what are all the things that make this up?
Yeah, exactly. And, the reason it becomes interesting is, like in the food industry, if you realize, well, actually this ingredient's gone out and it's, poisonous or something like that, you need to figure out where it's all been and who's all got that. And it's the same thing, or the idea is similar in the software industry. Can we figure out all the instances where this CVE or this version of the software that's potentially vulnerable exists? And we're not really there yet, to be quite honest. If you go to any enterprise company, they're not going to be able to tell you all the versions of all the software they're running, just because there's so much and it's all different formats, different places. So hopefully we are getting there. That's certainly something the industry is working on. But until we get there, SBOMs, I have to say, are of limited use. Okay, I have a list of the software in this container. Does that actually help me? Maybe, maybe not. In the future, when we have more tooling and when we have greater coverage of our platforms and systems, and when you have better tooling that sits on top of SBOMs, then I think it will be useful.
Right. Yes. So you're because there is definitely some skepticism about SBOMs in the industry. And I think you're kind of alluding to that a bit. It's only useful if everybody's doing it, right?
Yeah, effectively. Because the other thing is you get a lot of third-party software. So if I'm using third-party software in my platform or systems, then I also need to know all the versions of the software in there. Otherwise, I could be vulnerable to something and not even realize it. Right. So it does get That's not to say it isn't useful. I shouldn't imply it isn't useful until we have all that, because it certainly can be, but I think its usefulness is limited until we get better coverage.
Yeah. Yeah. So within SBOMs, you get, there's this term that we use, which is attestations. So can you just talk about that? What are attestations? How do they work?
Yeah, I mean, attestations are more than SBOMs and so on. An attestation is basically the idea that I can assert and prove that something happened or something is something. So like we have attestations attached to all our container images the signature itself, I think, is an example of an attestation. So our images are signed and that's attached as an attestation to the image. But you can also have attestations like this image was built on this build platform. This image passed these tests on this date, for example, and things like that. So attestations can be definitely very useful, and they allow you to prove things about artifacts' state and where it came from. So provenance is another big word that we allude to quite a lot in security.
Yes. So maybe to make this a little bit more concrete for people. So if you think of something about Log4j, because I think everyone knows the Log4j thing. So this was a fairly old at this point, but it was a zero-day exploit that was discovered in Log4j. Log4j is a very popular Java logging library, and it affected a whole bunch of different versions. So from 2 to, I think it was 2.1, 4.1 or something, that all of those versions were affected, I should say. And it was patched pretty quickly by the Log4j team, but there's an issue, and that issue is Log4j is everywhere, or certainly was at the time. Like, it was the sort of de facto standard for logging in Java. So like every Java app seems to be running about it. So how would having SBOMs help with something like that situation?
Potentially, yeah. So I guess you think of like a smart TV. So like Log4j was in a whole bunch of things like smart TVs that were very difficult to update. And I guess, I bet there's still vulnerable IoT devices with Log4j exploits out there. So potentially, yeah, that could definitely help. Like imagine you could see the SBOM for your TV and see if it's vulnerable. I guess you wouldn't do that yourself. You'd need, I guess all your TVs phone home now and it's automatically updating whatever. But yeah, it's getting to things like that. Like, can I tell if my devices are vulnerable as well as and artifacts? And yeah, if that makes sense.
Right. Yes. So I think where we're getting to is this kind of idea of defense in depth, that you can't rely on sort of one thing. So maybe could you talk about that a bit and how that would sort of work here?
Yeah, absolutely. First, I guess I'll talk about defense in depth. So that's just the idea that we don't rely on any one layer for security. So back 20 years ago, when I was working for the university, I remember being involved in a security incident. Not my fault, but one of our sites got hacked for a European project. And the hosting company, who will, I guess, should remain nameless, but they were a partner, and they denied responsibility or denied responsibility for a long, long time. And they said they were basically secure because they had a firewall, and the firewall only permitted port 80. And that was true. So like the hackers hadn't gone through SSH, but they were running an ancient version of PHP. So the attackers immediately got a reverse shell on PHP. And it was quite an interesting attack. And it took us a while to notice. We only noticed because if you Googled for our site, the Google index would show you all this like spam and sell cars and more nefarious things. And we're like, where's this coming from? But you went to the site, it was fine. And what they'd done is they'd put a little redirect in. So if you were the Google bot, you got one set of results. And if you were a normal visitor, you got the normal site. So that's why it took us a little while to notice. But yeah, that was fascinating. So defense in depth is not being that daft and saying, well, look, I got a firewall, we're secure. It's about, saying, okay, you got a firewall, but we still need to keep things up to date. We still want to keep things contained. So like if somebody breaks into this part, they can't get into the other part of our system. So never just relying on one level of security. Our CTO likes to talk about the Swiss cheese model, which is very similar. So you think about a slice of Swiss cheese with the holes in it. If those holes are your vulnerabilities, then any slice of Swiss cheese is quite vulnerable. But if you stack up a whole bunch of slices of Swiss cheese from different cuts of cheese, then, quickly get to a point where there's no single hole through all the cheese. So that's a very similar analogy. If you prefer food analogies. But getting to SBOMs, I guess SBOMs are actually less about security in the sense of defense in depth and more about being able to figure out what has happened later, perhaps. SBOMs certainly have a place in security, but it's less in the preventing an attack and more in the figuring out if you have had something exploitable at some point.
Right. Yes. Yeah. And obviously having a minimal container image is also helpful. But what are some of the other things that you would recommend people consider? What are some of the sort of standard things that you've seen?
Yeah, well, immutability is actually a big one. So we talked about that earlier with we no longer just update things and prefer to replace things. I mean, immutability can be great because you can say things like, well, this file system shouldn't be writable. And that can limit what an attacker can do, for example. There's also basic things that people still don't do, like signing container images is one I used to complain about a lot. So signing images can help you verify that you are getting the correct image from the supplier, that it's not been tampered with, nobody's changed it unexpectedly. But people still don't do that, even though we have tools like SigStore. So go and check out SigStore, which will let you easily sign an image. You don't have to worry about private keys. As long as you have an OIDC identity, it can use that. If you're on GitHub, you can use the ambient token in the GitHub image, and so it's almost automatic to sign an image. And then there's things like running as root. So definitely do not run your containers, the processes in your containers as the root user. That's just, that's really the first thing a lot of us look at. And then there's capabilities and RBAC. What would be other good ones? Yeah, definitely the size of images. So the smaller the image, the less tools in there, the less there is for an attacker to exploit. So one thing we talk about sometimes is living off land attacks. So that's where an attacker gets into a VM or a container and they use tools that already exist. So things like, SED or awk and chmod, etc., to further exploit and get higher levels of privilege. If you don't have those tools in the image, they can't use them to the attackers can't use them to further their privileges or whatever. Yeah, there's probably more to go on with.
Yeah.
Oh, yeah. Another good one that is worth mentioning because it's quite low hanging fruit is TruffleHog. So you get tools like TruffleHog that you can run on your images, your containers or whatever, and it will tell you if there's any secrets in there. So sometimes we accidentally check in a secret to Git, or we add a secret into a container image and we didn't mean to. Yes. Or we haven't realized we've done it. And that will find those and warn you. But attackers can also use those. And we actually saw that in the Shylid attack recently.
Oh, can you talk a bit about that then? Because that's really interesting too.
Yeah. So Shylid was it's actually, I believe it's the second wave right now that was announced today. I don't know when this podcast will go out, but we're talking about Shylid 2 this morning. But Shylid was so named because after the worm in Dune. So the sandworms in the Dune films were called Shylid. And this was an attack against the NPM ecosystem. And what it did was they managed to get the first victim through, I can't remember, some sort of spear phishing attack. But they got his credentials or her credentials and changed the package and uploaded the malicious version of the package to NPM. Then anybody that downloaded that version of the package also got compromised. And if they had access to any NPM packages, those were uploaded with malicious versions. And that's why it was a worm, because it self-propagated. Every time it found a victim, it would infect more people, if you like. And that's a definition of a computer worm, which is where the Shylid name came from. But one of the interesting things was, it ran things like TruffleHog to try and find secrets inside your laptop, or I think it also infected GitHub projects, and so it would search for these secrets, and then so the attackers could use them later and further compromise people.
Yeah, it was really, really interesting. And actually, I mean, at the risk of stating the absolute blindingly obvious, I'm amazed how often people still don't, kind of rotate credentials and that sort of thing. Like stuff we would think would be, surely we were past this, but we're not.
I actually wish I'd said that when I was talking about security earlier. I would say the number one thing that we talk about at Chainguard is have short-lived credentials, or avoid credentials if you at all can. Because a lot of the time you can use things OIDC now, so you don't need to retain credentials. But if you do, don't have them like a year long. Have them like an hour long. Yeah, that's quite a big one.
Yes. I feel I can't let you go without talking about XZ or XZ, or however we pronounce it, the XZ utils attack, because it's just such an extraordinary story. So very, very briefly, if people aren't familiar with this, there's a really good episode of Oxide and Friends, which is another podcast, where they interviewed the person who actually found it. So I'll get a link to that into the show notes of this episode, because that's superb. But it was an incredibly kind of nefarious attack in effectively in the CI/CD pipeline. And the very short version of it is, this was a campaign to insert a backdoor into the XZ or XZ utils project. It took about 3 years of effort. So from November 21 to February 24, the user going by the name of Gia Tan, and they gained access by basically getting to a position of trust within the project. I say they, I think we don't know if it's like one person or several people under one username, but either way, somebody or several somebodies were involved. So I guess, I mean, it's just an extraordinary, it's still one of those things you just like, that is an astonishing amount of effort. But I guess my question for you would be, are there things that Chainguard do that would have helped in that kind of scenario?
Yes and no. There's a few very interesting things there. One, like the amount of work they went to, like you said, gaining trust. I think it's very hard to think of an open source project that would be immune to that, to be perfectly honest, especially a small one. Because, they'd kind of done their due diligence, right? This person had been around for a while. They gained their trust by creating like PRs that were reasonable. So in that sense, that's not something Chainguard can help with. There are a few interesting things though. Part of the exploit was only in the uploaded binary, like the released file. It wasn't in the source code. Some of it was in like tests and stuff. But part of the exploit was only in like the sort of release process script. I think that was only in the tarball. It wasn't in the actual GitHub. I can't remember if it used GitHub, but it wasn't in the actual source code. So one thing we try to do at Chainguard is build everything from source. And that also goes for all the Shylid attacks, right? Because the Shylid attacks, they did a npm publish or whatever the command is to upload a malicious version of the package. That package then no longer matches the version in their GitHub. So one thing we do at Chainguard is try to build everything from source. So with the container images, we're building everything from source and trying to avoid using tarballs now. We try and go to do a git checkout to make sure we get the latest source code and use that and avoid using the tarball, which means we wouldn't have got that specific part of the malicious code. And we actually have a Chainguard libraries product now. So we've just launched recently and we're working on NPM, which I believe is still in beta. Maybe by the time this podcast goes out, it'll be GA, I'm not sure. But anyway, what we do is we build everything from source. So like any Shylid attack won't affect us because that only exists on NPM and not in the GitHub source. So the attacker would need to affect the GitHub source before we pulled it in. Yeah, I think that's the main ways that we would protect against that. Right.
Fantastic. Thank you. If people
I should say,
go on. Yeah.
I guess I should say, although, we would protect against the NPM version, but we don't, like XZ was as a C library, so we don't offer like a libraries product for C.
Right. Got you. Yeah. Okay. Thank you. So if listeners want to learn more about Wolfi and Chainguard images and all of that, where should they go? What learning resources do you have and what have you?
Yeah. So obviously it's the chainguard.dev site, but what you'll find there is edu.chainguard.dev. And that's the Academy site. So I've been heavily involved there and the team I work with, and we've created a whole bunch of tutorials and just help on using Chainguard images, but also Distroless images and our open source tooling. So there's a lot there, not just for customers, but also new users and people that want to find out more about Distroless images and security.
That's brilliant. Adrian, thank you very much indeed for taking the time to chat to me on this episode of GOTO Unscripted.
No, thank you very much for having me, Charles.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.